So here, let us get everyone in here, and then we'll chat about this. Okay? Thanks. If you only got one haircut, you got ripped off.
I don't shave, I remove my mustache.
If Jacob only got one haircut, he got ripped off.
Ha, 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 ha. Oh, Dad,
I got my hairs cut.
Dad, I'm very sick. I'm very sick. I'm Dad.
No.
Dad, I'm terminally ill. I'm terminally ill.
All right. So, moving on. Here's what we want to talk about. Is Lauren here today?
No. Neither Chris.
No, Lauren.
They both were hit by balls.
They playing hooky.
You never asked about Chris.
I was about to get to Chris, but Chris is often late. Lauren's normally on time. So, right. All right. Here's what's up. We talked about graphing form because, and you should remember this real quick because we talked about all of this with HK being the vertex, the graphing form being the perfect square factored with any coefficient to your x factored out, and anything that makes it not perfect added or subtracted on. The trap door, or the thing to be careful of here, was that it's x minus h, so we actually end up using the opposite value of what it looks like in the parentheses. So if it's x plus 5, my h is actually negative 5. This is the exact same rule set as absolute values. So where our debate is, so you chose a really bad time to come up and ask a question. Where our debate of what we do today, I'll take your question, but not in the middle of a sentence, is can we move on to 914? And I won't make you do 913 homework if you if you didn't do it, or I don't even know if I told you to do it or not. That was 2 weeks ago. This works the same. So if we think we're comfortable with 913, I mean, we could do a few of the practice problems if we want. But we went over this stuff of how do I get this into perfect square form, look at what h and k would be, and then move on from there. Where it gets tough, problems like this, well, tougher, where we have a coefficient that we have to factor out and things get a little bit messy. So, what do we want to do?
Get my table.
Yes, that would be a priority. So, think about that for a moment. Satya, what did you need to do?
Nothing.
Nothing.
Chris left his stuff in my binder, and I'm not responsible.
Okay.
Jacob just handed it to me. Mr. Hudson, trying to hold on to it.
No, but I'll put it in my room and then
I've lost 2 units of homework. I don't want to do that.
The whole thing.
No,
Right.
It
is on the table of the knowing section.
We can just check the video and see if we did that.
I mean, we did it. We went over it.
I have no.
Yeah, we went over it. I just don't know how comfortable we ended up with
Oh,
it.
that was when I was touring. Going around to
Yeah, that might have been an OEP day or a 6th grade visit. No, I don't think it was 6th grade, but we're beyond all those. Can I help you, Miss Rosie?
I just want to let you know that was the wrong index.
Oh, okay.
That was for the OGT.
Oh, we were just talking about the OGT last, a couple days ago. But yeah, here's what you
It's
were.
not fair when you go to that site and see calculator policy to give you one link.
Well, so
Only for
this
the OGT.
this is the same calculator
It's
we
the
use
same.
for the 30x2s, which is just the standard one.
So
Which
we're
also
ordering- we're ordering 30.
The multi-views are the same thing, but we like how the screen. Sorry, did you get the multi-views or the regular? Okay, sweet. Cool. Thank you very much, Miss Rosie. So, if we look at 6, part 6 here, what would be the vertex of part 6?
You're in the way.
You're in the way, Satya.
Put his hand up in front of eyes, you're in the way.
So guys, also what this comes down to, as we talked about before break, is we don't have enough days to cover everything we need to. So that's why I'm trying to move on to 914 if we're able to. So this is all algebra to get to this point. But then once we're at this point, right? This is showing the algebraic process all the way down to step 6. Now, there is an error here, but if this was what we had, what would be the vertex? Jacob?
-3, -32.
-3, -32, right? The opposite of what this looks like, and exactly what this is.
So the A value has nothing to do with the vertex, so.
Correct, because the intensity of the parabola doesn't change where the vertex is. It changes how tight or how wide it is.
I thought it'd be like -6, -32.
Nope.
I mean, but yeah, no.
So are we good now? Now, if we follow her process, we can find the mistake. Right, we add 23 to both sides, then we factor out a -2, and then what happened between steps 3 and steps 4? What?
She added 9, but then she added it inside the parentheses.
Why did she have?
Now wait, why was she adding 9?
To make it a perfect square.
To make it perfect square.
But when she adds it in the parentheses, it makes it -18.
She actually subtracted 18, or added a -18.
As Chris would say on behalf, since he's gone,
She done goofed. So this +9 should actually be a -18 because that's what happened over there. Right? When I add a 9 here, what it actually changes is -18 on that side, so then I have to do the same over there. Does that make sense for where that? And that's a minor error, but that is something to be careful of, is if you've already factored out and then you try to put it in the perfect square form, that is not, like, it's not 9. It's actually -18. Very good. All right, we can cycle back to 913 later in the week if we need, especially since Lauren and Chris aren't here. But let's for today go ahead and talk about absolute values. You may want Desmos to play with. I know Satya is getting on his computer now.
It's a laptop.
It's a computer.
A laptop
What you said is right. What I said is right.
The calculator.
They're the same thing. What?
Boy.
Oh.
Don't discriminate.
That means-
Dude, a slide rule is a computer. It computes things.
That little thing where like you wait, no, that is what it's oh
I submitted you guys' video, by the way.
we need a light bulb. Oh wait, did we watch oh never mind, I'll watch that.
Maybe if we have time at the end of class, we can show you. I
yeah.
gave it the title of Wizardly Worries.
Did we get test back?
No? We might still need to finish them. Remember I gave you, well, I don't know who was here and who wasn't here, but I actually gave you guys the wrong test.
Yeah,
And
we
then
did.
we did
Yeah.
our test.
So,
Except the other test was super easy.
exactly.
Yeah.
For you.
So, you already saw where this,
It was just hard for you because you missed like
No, you're something with that night test.
Oh.
I'm talking about.
I'm just waiting.
yeah, so am I. Apparently I have no internet.
Actually, no teacher should ever do that. You guys are great. You guys suck.
You guys.
In all seriousness, though, let's talk about absolute values. So we know that the absolute value function, what the absolute value actually does is make things positive, right? But really, what is absolute value talking about?
Talking about how far away it is from 0.
Distance from 0, right? So, -9 is 9 away from 0. 7 is 7 away from 0. Radical 2 is radical 2 away from 0, and negative radical 2 is still radical 2 away from 0. So now, if we have an output and we're trying to determine the inputs, who can spot some potential issues? Thomas.
Find 2 possibilities.
There are 2 possibilities, because if my output is 4, my 2 possible inputs, positive and or -4. If my input's -16, the output is 16, and that doesn't leave any question. But if my output's 9, the input could be positive or -9.
That's not possible.
Now, if the input's -3,
Oh,
You messed up.
that's the output. Wait, that's the Chief?
sorry, the output is negative. we're negative 3 away from 0.
In that case, you're finding a fifth dimension.
In that case, you're wrong.
That
Hold on, let me
doesn't
call
make
911 for
sense.
Chief.
In that
So,
case, you're going into
This is where you guys as a class just kind of steamroll over these teachable, which is okay. But like this is that teachable moment of like, so domain and range, right? Let's bring this back to where this comes into the graphing world. This would determine what is our acceptable domain and what is our acceptable range of values for the absolute value function, because we know that we can't have outputs that are negative unless something's been done to the initial function, right? So if we make the graph of absolute value of x, I think we know what it looks like. Just a v, right? That perfect slope of 1, perfect slope of 1 from your perspective, perfect slope of -1, and it doesn't go past the negative, or like into negative values for y, right? So we won't graph that right now. But what if we wanted to change the graph then? So if you have Desmos, or I'll put it up here, let's play with what changing the graph does to end up with something like in 40, or if we have a 4/5 absolute value x minus 2, and then on the outside minus 2. So
Can you get absolute value?
you can type ABS parenthesis, or you should be able to click it in the symbols. So
ABS absolute
not in the
value.
symbol.
He said ABS parentheses. Yeah. That's what I typed.
So f of x, we're going to go ahead and define the function like this,
Where's the question?
is, oh, you can also just vertical bar. So Satya, above your enter is vertical bar.
Oh, shit. That's what that's for.
I'm going to assume you said shift,
I did say
as in the shift key.
I didn't say shit.
We will move forward with life, assuming.
Sure.
Sounds correct.
All right, what's your hypothesis if I put a multiplier in front of it?
It's going to get wider.
Wider or narrower?
What? Huh.
Narrower, right? So a large coefficient makes it narrower.
Wait, that's always
Yeah.
No.
Yeah, I know.
Well, no, it looks like that one show looks like NBC where it has
Yes, the peacock. The fraction coefficient makes it wider, right? Same thing with our quadratics. Remember x squared versus 1/2 x squared or 3x squared, right? It makes it go up faster. Thomas?
Question. Does this mean that you can't do absolute value on both sides of the equation, and there isn't a opposite, like there isn't an inverse of absolute value?
That's a good question. Well, so asking about absolute value on both sides of the equation, that's a hairy question because it depends what we're doing with the equation. If we know the things inside the absolute value or not, that comes down to how many unknowns do we have. Is there an inverse to absolute value? I don't know. I mean, when we look at doing the function backwards, we're saying what values could be this far away from 0. So I guess the inverse is kind of like the positive and negative of whatever our end result was, right? What'd you find, Mid?
It says that there is an inverse, but that's not a function. That's called default.
Yeah, that makes sense. Because remember, to be a function, it has to be able to pass the vertical line test. So although something can exist, it might not be a function. So like, if we say x equals y squared, that's not a function. It exists. We can do it. It's a relationship. Remember, this is not a function because it doesn't pass the vertical line test. So then, this should be kind of straightforward, hopefully. If I add, like, I don't know, 3, what do we think is going to happen?
It's going to move to the left.
Going to move left, right?
Plus,
If I subtract something on the outside, it's going to go down. So, same rules as our quadratics, right? Intensifier changes steepness. Adding on the inside of the function changes left, right. Adding on the outside of the function changes up, down. Any questions? Well, that's these, the intensifiers. Or are you talking about inside?
what would do I?
Outside, but like negative.
Oh, it flips it. Yeah, so same rules as quadratics, right? Every rule literally holds true the same. Because really, it's not the rules of quadratics. We were talking about the rules of functions, right? If I take the opposite of the function I had, it flips what the function looks like. Nid? What do you mean?
Like absolute value of 5 over 2, like that.
That, it's the same thing as multiplying by 1/2. So it makes it wider, right? So always think about trying, like, remember, division doesn't exist. It's multiplication. Subtraction doesn't exist. It's addition of a negative. So quote unquote.
Wait, which one is it? Is it cold or hot?
Cold doesn't exist.
Okay.
It's lack of heat. All right, so this. Tell me, like, write out. Actually, please on your paper, go ahead and write this out. Like g of x equals 4/5 absolute value x minus 2. Close it minus 2. Which actually we can use quantity to say things like that. So I want you to kind of use arrows, and I'm going to switch my screens around, and indicate what each part of this does. So don't say moves it. Say moves to the, like left or right or up or down. Don't just say changes intensity or changes width. Say opens wider, opens narrower. So our g of x. If I say parent function, have we gotten comfortable with that yet?
Yeah. Also, when you try to type g of x or stuff like that into Desmos, it doesn't work.
Yeah, it wants f, I believe, or you have to change some settings. Really, and the reason that Desmos doesn't need to do that is it uses colors. So instead of saying compare h of x to g of x, we can say compare red to blue. You don't have to type in y equals or f of x equals. You don't have to type in any of that. You can just type in your function. Yeah, that's why Desmos set it up like that. So you could use like red could be r of x, green could be g of x. Like, yeah. My 4/5, since it's a fraction and it's less than 1, makes it wider.
I gotta go to a good drink real quick.
My -2 on the inside. For the what?
Oh, I think you're talking about you moved it, right?
Yeah, right to. So we have widen, move right, move down. So if on a test, so I'm debating whether I just hand you guys back the same tests again, or whether I write a different chapter 9 test. If you were asked, describe the transformation compared to the parent function, you don't really have to be able to definitively talk about the widening, right? It's an intensifier of 4/5. We could do some calculations and get some actual values. You just want to know it gets wider, but here you want to be able to specifically talk about the shift left, right, and the shift up down. Questions?
So if the number outside of bars is greater than the
Yes. And if it is negative, same rules for less than 1 or greater than, but like upside down, right, flipped. And honestly, guys, especially with 2 people gone, that's really all we needed to cover today. That's why I was saying, like, it's just an extension on what we've done with parabolas and what we've done with quadratics. Really, I'd like you to spend this time to go ahead and knock out the 914 homework first, but then I'd probably say go back to 913, and especially if there are ones that make you perfect square, like force, like you could skip 30, that's probably not very necessary. But if it makes you actually do the work. So I can leave 914 up here if you guys want to be able to see that.
So I'm going to use the